Welcome. In this video, we are working with integration by substitution to evaluate the definite integral from 1 to e squared of the natural logarithm of t divided by t with respect to t. This one is a little tricky since it doesn't quite look like a substitution problem. So really quickly, I want you to notice or recall from previous classes or earlier in the semester that the derivative with respect to t of the natural logarithm of t is just 1 over t. This means I can let w equal the natural log of t, then dw equals 1 over t dt. I'm going to give this a quick rewrite to see if you're following or seeing what I'm seeing. I have the integral from 1 to e squared of ln of t times 1 over t dt. Do you see it? That is, do you see dw? I see dw right here. Since these quantities are equal, I can replace that with a dw. So this becomes the integral, and I will get to the limits of integration after we've figured out the integrand of w. Since the natural log of t, we said let that equal w. So there's our w. And then here I have my dw. And now for our limits of integration, let's start with our lower bound. Our lower bound is 1. So when t equals 1, w equals the natural log of 1, which is 0. Now what about our upper bound? When t equals e squared, w equals ln of e squared. This just equals 2. So now we can actually find our antiderivative of just w. That's w squared over 2 from 0 to 2. So this just becomes 2 squared divided by 2 minus 0 squared divided by 2. That's just 4 over 2, which is 2. And now we can quickly do a check on our work, and I'm going to focus on just the indefinite integral. So if our integral were the natural log of t over t dt, we figured out through substitution, again, I'm using the same substitution, that this is w squared over 2 plus c. So replacing w with a natural log of t, we end up with a natural log of t squared divided by 2 plus a constant c. To check our work, we need to find the derivative with respect to t of the natural log of t quantity squared divided by 2 plus c. This is equal to 1/2 times the derivative with respect to t of the natural log of t quantity squared plus the derivative with respect to t of c. So this is 1/2. And now we need to use the power rule to multiply 2 times the natural log of 2. This is our inner function. This is our outer functions. So we took the derivative of the outer function, and now we need to take the derivative of the inner function. The derivative of the inner function is 1 over t. What I did there in the second step was apply the chain rule. Then the derivative of the constant c with respect to t is just 0. So this becomes the natural log of t over t. Since this derivative matches this integrand, our answer is correct and we are done. I hope this video was helpful.